The time before 1.5 degrees Celsius of warming feels like eons ago. But in reality, it was just a few short decades back. However, even before we hit that critical threshold, blowing past our previous estimates, climate change was extending existing inequity in treating diseases like malaria, HIV, and tuberculosis, which have all increased in distribution across the world as climate change has accelerated the ripening conditions for them. Years ago, scientists did groundbreaking work in the field of mRNA research, which exploded with the COVID-19 vaccine. Shortly thereafter, anti-malarial vaccine proposals sprouted up. Others followed suit. However, in the pandemic sense, we have not seen a swift and immediate eradication of these deadly diseases. Instead, the centralized vaccine production model has grown increasingly strained and ineffective at distributing life-saving aid to people that need it most. And medical copyright has prevented countries from manufacturing their own versions of vaccine that would ensure a slower progression or halt of the pandemics that have raged since. As sea levels rise, we've turned to look at deep ocean life, not as a source of fear or anxiety, but one of inspiration. Coleoids can build shelters, disguise themselves, and contain the unique ability to shift their RNA on command as a response to stimuli. By applying that methodology to an external vaccine-producing membrane, we're able to periodically update the function to produce new, unique, open-source vaccines, which would allow communities barred from copyright access to produce their own specific iterations for their surrounding community. We took inspiration not only from the coleoid when it came to creating the visual identity and biological structure of the Coliopod Kit, but from what was, in the decade we founded our organization, an emerging field of dry vaccine patches, which were created by making a layer of plastic microneedles with a powdered vaccine solution applied. By the late 2020s, these proved effective in human trials, which in theory should have increased the reach of vaccines across the globe. However, in the early 2030s, the result followed in the same footsteps as the lack of vaccine access before it. In countries where this breakthrough was created, children, infants, and people unable to receive traditional injectables benefited massively. But intellectual copyright toward the patented microneedle technology, as well as the vaccines being applied to the patches themselves, prevented millions of people from receiving mRNA vaccines that no longer required refrigeration or needles. By the 2040s, the vaccine producers halted patch distribution after the manufacturer made the switch back to traditional injectable vaccines, citing growing supply chain issues. Since then, we've been working to develop our own adaptable, equitable solution to vaccine access, and to us, through our open source Coleopod Kit, combined with more equitable distribution, we can help ensure more people have access to life-saving vaccines. The Coleopod Kit, or Colio Kit for short, places the opportunity for adaptive vaccine patches in everyday people's hands, in a variety of conditions and environments. The prepackaged version comes with an inoculated cellulose-like membrane organism, which, when activated with water, will begin sprouting vaccine patches that can be distributed locally and kept indefinitely at room temperature while attached to the membrane. When a new variant emerges or another disease approaches, requiring a different vaccine, a follow-up kit will be sent out. If a follow-up inoculation solution is, for whatever reason, unable to be shipped directly, and your community has even a rudimentary microlab made using off-the-shelf components, those formulations could be synthesized with our online documentation. Additionally, countries, governments, and external aid foundations could all take advantage of the Coliopod's open source framework by either collaborating for their own form of distribution or working directly with our organization. This ensures that the Coliopod remains adaptable. Even if the tides of funding dry up, people aren't left in the cold. By taking influence from a myriad of successful organizations with the goal of democratizing medical access, we realized that one of the best approaches to aiding people to take charge of their own vaccine production was to follow a model of open access to information, which is why the formulations, schematics, and guides for the creation of the Coleopod Kit and follow-up inoculations will always remain transparent and open source. By creating an intuitive instruction set and straightforward design, anyone will be able to help democratize vaccines. What differentiates the Coleopod Kit, other than its ability to help aid in creating equitable distribution, is how it adapts not just to situations, but how it adapts its function. The ability for our kit to periodically change its function, switching either for the manufacture of patches for different diseases or a new strain of disease, is made possible through RNA. RNA stands for ribonucleic acid. Every cell in our body has RNA, and it's our cell's way of taking instructions from DNA and figuring out what proteins to make. All types of RNA are involved in building proteins, yet mRNA is the one that actually functions as the messenger. mRNA specifically has the recipe for making proteins. The most important element of RNA, as it pertains to the Coleo kit, is that actual coleoids in the ocean are able to shift their RNA in response to stimuli. We've taken that ability and infused it into the kit. Coleoids have the ability to edit their RNA, changing encoded proteins faster than DNA mutation. Compared to humans who can only edit a few dozen of our 20,000 genes, coleoids can edit more than half of their genetic transfers. RNA editing has an advantage over something like CRISPR or gene therapy in that it is scalable, reversible, and not permanent. That means if a formulation only changes slightly over time, we can make tweaks, and if it changes drastically, you aren't stuck with an ineffective, unchanging solution for inoculation. Working to give people the chance to produce their own stable vaccines, whether they're in a hospital, a war zone, a suburb, or a city, is incredibly important. But without the ability to shift RNA, our idea would have been incomplete. That's why we spent years iterating and prototyping on our concept, returning to the drawing board again and again until we could answer yes to the question, will this truly help democratize vaccine access? Equity isn't automatic. In order to create a more democratized form of vaccine access to prevent further exponential loss of life to climate change-enhanced diseases, we need to create more open, nuanced, and accessible design. And the Coleopod is a step in that direction.